So let's give that first question a bash. This document that I'm working through, this PDF, is on the Google Classroom. So if you would like to, check it out and actually have the document in front of you, you can do that. You can print it, whichever it is there. But yeah, give this question a bash and put answers into the chat when you get there. Put a question mark in the chat if you want a hint. Cool. So always in any geometry question, you have to use all the information before you're ever going to get there. So it starts by saying it's a right-angled triangle. Now, in my mind, generally, if they say it's a right-angled triangle, what is that telling me? What is something that I know about right-angled triangles? You can put it in the chat there, Pythag. Okay, so I'm automatically thinking this potentially has something to do with Pythag. Okay. Then I carry on reading. Not necessarily. Maybe we're just going to be using the angle. I'm not 100% certain. But it also says an ABP is an isosceles triangle. All right. So fill in all the information that you know about an isosceles triangle and see if you can use that to somehow get to the length of AC. Cool. It's an equilateral triangle. All sides are equal, but more than just all sides are equal. There's something else. Okay, so I've got an answer there. Cool, so Pooja used that. So often, again, when I do geometry, like sometimes I don't see the answer immediately. So I'm going to take everything I know. I'm going to fill in everything that I know, all the angles, all the sides, as much as I can, and hopefully that'll lead me to somewhere. All right. So I know that all the angles are 60. All right. So that's 60, that's 60, that's 60. Fill in all the other angles for me and see if that helps us. So I've got two answers there, not quite sure if they're right just yet, so keep on going. So, Ruan, they're asking for AC. I think you might have calculated BC. Cool. Caleb, 100%. So fill in all the angles that you can. All right. So let me go a little bit further. All right. I saw Caleb say there that angle APC, that's this angle here, is equal to 120. That's absolutely correct. That is angles in a straight line. Okay. I don't know how that helps me just yet. Let me carry on. So, this whole angle is equal to 90, and if this piece is equal to 60, it means that this is equal to 30. 100% Roland, because that is, yeah, that those add up to 30, and this angle there, that would be ACP, Caleb, is also equal to 30. Now, what do I know about the second triangle? Yeah, it's an isosceles triangle. That's excellent. And if this side is equal to 2, it makes this side equal to 2 as well. And now, again, let's go back right to the beginning. If I know that this is a right angle triangle, I know this angle is equal to 90, I know that this whole hypotenuse is equal to 4, then I can use Pythagoras, and I can say the short side squared plus the other short side squared is equal to the hypotenuse squared, and I can get to 4 squared minus 2 squared. So this is 16 minus 4 is 12, and so AC is equal to root 12. Okay. Awesome. That's it, Romeo. Excellent. Okay. So, is everybody happy? Are there any questions with that? Again, I think it's so crucial. Like even in core maths, like this is a trigger. If you read right angle triangle, I'm automatically thinking Pythag. Is it going to be? Not necessarily, but it's a trigger. When it says equilateral triangle, all right, automatically I'm thinking 60, 60, 60. I'm thinking all the sides are equal, and then I can kind of work through stuff. But none of the stuff that they give in the question is going to be random. There's going to be no distractors generally. Everything is going to mean something, and I have to use absolutely everything. So if you're stuck, read the question again and see if you've used everything. Okay, cool. Let's do this question here. Is that a question, Maureen? All right. So, in my mind, when we have a question like this, we're going to do one later. Another one like this. Our whole idea is if they ask what is the value of m, m is the angle, and so what I'm looking to do is set up an equation. All right, they've gone and told me that this is 30 degrees. Not necessarily, Luyanda. You could figure out the angles on the other side using angles on a straight line. All right. So somehow I need to set up an equation with all of these things, and then somehow I need to use this here to kind of only make that equation in terms of one variable. Okay. So in my mind, start by setting up an equation. Once you've set up an equation with all the angles that you have there, then try go from there. All right. Once you've done that, then you can then put another question mark in the in the chat if you want another hint. But yeah, set up an equation first, and then let's see. John, no, not necessarily. Could be scaling. Could be isos. It could be equilateral. I don't. Well, it can't be equilateral, but I don't know. So I've got an answer from Luyanda there. Not quite sure if that's right. Let's keep on going. Okay, I've got an answer from Caro. You can if you want to, Andres, you don't need to. It's not necessarily an isosceles triangle, Romeo. Okay, so I'm going to start by just setting up the equation. And then we can see. All right. So I'm going to. I didn't use exterior angles of a triangle. So can you? 100%. I didn't. Probably might have been easier to use exterior angles of a triangle, but whichever way, you're still going to get there. So I don't think so. No, Merlin, no. Mr. Smith, Afif, no. Nao, no. Keep on trying. All right. So I'm going to start by setting up the equation. I'm going to say all of these angles are equal to 180. So I'm going to say 30 plus 180 minus m plus 180 minus n is equal to 180 degrees because of some angles in a triangle. Okay, so again, you could have used exterior angles, but I don't know. That's kind of how I did it. Yeah. Okay, cool. So now I'm going to simplify a little bit. And what I'm going to do is where did I go? Here. Both of these are negative. So I'm going to take them to the right-hand side, and I'm going to get m plus n on the right-hand side. And on the left-hand side, I'm going to get 30 plus 180 plus 180. And then I'm going to subtract that 180 on both sides. And I'm going to get m plus n is equal to 210. Okay. All right. So, so now I've set up an equation. All right. And I've used the information that they've given me on the sketch. But the one thing that I haven't used yet is that m is 3/4 of n. So I can say m is 3/4 of n, okay? And so I'm just going to go back to this equation, and wherever I see m, I'm going to replace it with 3/4 of n. So I'm going to get 210 is equal to 3/4 of n, because that's what m is, plus n, all right? And now this is just an equation. Actually, let me keep that. Now this is just an equation that I need to solve. All right. And I'm going to get 210 is equal to 3 over 4n plus 4 over 4n, because 1 is equal to 4 over 4. And if I do that, I get 2010 is equal to 7 over 4n. Is everybody there? Okay. Now, to get n alone on the one side, I'm just going to multiply by 4 over 7 and multiply by 4 over 7, because what happens is the 7s will cancel out, the 4s will cancel out, and all I'm going to be left with is that n. And now I know that 7 goes into 210 30 times, and so I'm going to get n is equal to 120. And what did they want? They wanted the size of m. And I know that m is equal to 3/4 of n, which is equal to 3/4 of 120. 4 goes into 120 30 times, and so m is equal to 90. Okay. So Caleb, are you with me? That I'm here. I'm going 3 over 4n plus, and let me go like this, plus 1n. All right, but again, I can't add those, and so I changed this 1 to 4 over 4. All right, because once I've got 3 over 4 plus 4 over 4, I can add them and get 7 over 4. Does that make sense, Caleb? So, Callum, I wanted to solve for, and I could have actually subbed in n, but the point is at this equation here, all right, you can't solve for m and n, because m and n can be there's an infinite number of solutions to that equation, because there's 2 variables and they're equal to 210. So I don't know what the answer is. And so I want to get an equation with just one variable, only m or only n. Because once I have an equation with just m or just n, then I can solve for n or m, and then once I have the one, then I can solve for the other. And they told me here, Callum, that m is 3 over 4 of n. So I've just gone and written that. M is 3 over 4 of times n. And so I know that m is equal to 3 over 4m. And so where I saw this m there, I replaced it with 3 over 4n. And so then I ended up with an equation of only n's, and that I can solve. Okay. I'm not sure if you can, potentially Romeo or Renono, but it sounds like that could be an option. Okay, cool. Are there any questions with what I've done? There's definitely other ways to do it, potentially, but are we happy with my way? Okay, cool. All right. Do this question for me, please. I'm just going to go fill up my coffee. I will be back in 2 seconds. Give this question a bash. All right, so I've got a whole bunch of 270s coming through. All right, So I think the way that I would always do this is, let me turn on my pen, sorry. What I would do is I would completely ignore this for now. Okay. And if I do that, is everybody happy that oh, hectic, my pen is still big. Let me make it small again. W plus Z is, oh, sorry, I lie. W plus Z plus 45 is equal to 180. And so W plus Z is equal to 135. Okay, cool. So I know these two add up to 135. All I need to figure out is what do these two add up to. All right. So let me put those back in and let me go and take out. Oh, that was quite big. Let me do that pen size. All right. Let me take out this. If I take out this, all right. Does everybody see that I can do exactly the same thing here now, and I can say x plus y plus 45 is equal to 180. So x plus y is equal to 135. Awesome. So now what do I have? Is the yellow is equal to 135 and the red is equal to 135. And so this together is going to be 135 plus 135, which is equal to 270. Okay. Cool, guys. So I think there, often what works is just to kind of, isolate which triangle you're working on and then work in that triangle. Alternatively, did anybody do this by inspection by just assigning random values to the angles, or did everybody do it like, who did it like I did? Who did it by assigning random values? Put it in the chat there. Type good to this. Okay, cool. Okay. Alternatively, if you had assigned random values, it also would have worked, but yeah. Okay. So there we have that question. Very similar question here. Give it a bash. Inspection, Romeo. Cool. That's fine. So inspection is fine for Olympiad because you don't need to show reasoning. If this was a core question in an exam or a cycle test, you would have to do it like I did. I didn't put in reasons. You would have to put in reasons, but yeah. I put that question in one of my cycle tests before, and I didn't accept assigning random values. That you can only do with Olympiad. I'm getting a whole bunch of 2 N's. Not sure if that's right. Keep on going. Cool. So someone put in the chat how they got those answers. Exterior angles. Perfect. All right. So everybody, exactly like I did in the previous question, I'm just going to ignore that. Is everybody with me that A plus B is equal to N because of exterior angle in a triangle, right? And then similarly, if I go and erase the other side, so if I go erase all of this, is everybody with me that, again, similarly, C plus D is also equal to N because of the exterior angle of the triangle. And so therefore, this is equal to N, this is equal to N. And so therefore, the sum of A plus B plus C plus D is equal to 2N. Okay, so Sumaya, that was a nice summary. Excellent. Okay, cool. Let's go to this question. Okay, so whole bunch of answers coming through. This is nice. So what happened there? Sorry, let me just go back. So what I'm going to do is all of these are right angles. All right, so if I draw a line down here at right angles, that would make this a rectangle. Okay, and so then this would be equal to 4 and this would be equal to 10. And if this length is equal to 10 and the whole length is equal to 13, that would make this 3. All right, and now I've got a right angle triangle, and this is nice because it's just a 3, 4, 5 Pythagorean triple, and so I can just automatically say AD is equal to 5 because of Pythag. Okay, cool. So yeah, excellent. Okay, let's do this question. This question is quite challenging. Again, when I did this question, I didn't see it automatically. I just kind of started messing around and filling in as much as I can, and just like somehow, if they ask me to calculate X, probably what I'm going to have to do is set up an equation. All right, so somehow you just need to fill in as much as you can until there's some sort of equation that you can pull up, set up, and then do. Okay. So for those who need a little bit of a hint, did you do this question yesterday, Isa? Okay. Okay, so the two red lines are equal, meaning an isosceles triangle. The two yellow lines are equal, meaning an isosceles triangle. Okay. So I've got a whole bunch of 20s coming through. Not quite sure if that is right, so just keep on going. For those of you putting answers in there, did you use algebra or did you assign random values to B and then work from there? Just out of interest. Algebra. Okay. Okay, random values. That's fine, Romeo. All right. So, I did it algebraically, and again, my comment is this: are there multiple different random values? Okay, cool. That's fine, Haley. You do need to get good at algebra because sometimes random values isn't going to work, and so you need to actually be able to do it without random values. So that's something you need to work on going forward. For the first round, that's absolutely perfect, but hopefully you get through to the second round, and then a lot of that stuff you're going to have to be able to do without, and so you do need to work on your algebra going forward, especially going into grade 10 and the senior rounds. But cool. All right, I'm going to do it algebraically, and yeah. Okay, cool. So they've told me the two red lines are equal, AB and AC. I don't know quite how I'm going to link that to, and again, this is my comment again, is some of you who did algebra probably did it completely differently to what I did, right? So you just kind of filled in values all over the place until it worked. Absolutely fine, all right? But yeah, there's always going to be multiple different routes, and my route might not even be the quickest. Like it's always what I tell my students is I'm not necessarily going to get the quickest route every time, but I back myself to get there. You just need to play around until something pops up. Okay, cool. So that the two red lines are equal, so that gives me an isosceles triangle, and yeah, I can't relate it to X just yet. So I'm going to go and call these guys Y and Y, because the base angles of an isosceles triangle are equal. Okay, is everybody with me? Okay. Then I can go further and I can say, if I look at, and let me just remove all of that. If I look at this triangle there, is everybody with me that this is the exterior angle of the triangle and this is equal to X plus Y? Everybody happy? Cool. And if that angle is equal to X plus Y, they've told me that these two yellow lines are equal. So I've got an isosceles triangle there, and that must also be equal to X plus Y. All right. If I now look at this triangle there, all right, does everybody see the exterior angle is equal to the two interior opposite angles? And so I can go set up an equation and I can say y plus 40 is equal to x plus y plus x. Again, what was I looking to do? I was looking to set up an equation. That's the whole point about questions like this. If it says calculate x, you literally just need to fill in angles until somehow an equation pops out. Okay. What I do see is that the y's will cancel because I've got a y on both sides, and all I'm left with is 40 is equal to 2x and x is equal to 20. Okay, so again, if you assigned random values, also probably would have got there. Yeah, but in my mind, yeah, it's good to be able to do this algebraically because going forward we will need that. Okay, any questions? I'm sure that a lot of you who got 20 did it differently. Did anybody do it differently? Who did it exactly like I did? Anybody else do it differently? Just put it into the chat there. Can you guys still hear me? Did you guys do it the same? Did you guys do it differently? Okay, same. Okay, fine. All right. Alternatively, what you could have done is you didn't need to use the exterior angle. You could have said, if I look at this big triangle here, then I can say this angle there is going to be 180 minus y, this one here, minus 2x plus y. And you could have solved for this angle, and then you can set up an equation with all of these, and then you can go from there. All right. So however you do it, all right, you are going to get there. You just need to somehow, play around until an equation pops out. Okay. We're going to move on. Pooja, sort of the same. Okay, fine. All right. So did you just set up an equation differently, huh? Issa, how did you do it? Okay, so again, Pooja, there's so many different equations that you can set up. So differently, Issa, but did you also somehow set up an equation? Okay, 100%. So again, Issa definitely used the two isosceles triangles and somehow set up an equation. However you do that, you're going to get to the same answer. Okay, hit this next question. I don't think so, John. Keep on trying. I don't think so, Joshua and Petrus. So John, just look at the direction of the ratio. Okay. All right. Cool. So, let's do this question. Let me draw a rectangle. Now, my comment is also, with questions like these, can you just randomly assign values? Absolutely. Sometimes these questions are easier if you randomly assume values. So, however you do this, all right, if I randomly assign values, so it is also going to work. We'll talk about a more algebraic approach now, but yeah. Okay, so if I go and say this is 4, the whole length, and this is 3, the whole length, then the whole area is going to be 4 times 3 times 2, which is equal to 24, right? And then if I just randomly split this up and I say, cool, let's make this 2 and 2, 2 and 2, 2 and 2, and I make this 1 and 2, 1 and 2, 1 and 2, all right? If I go add up that perimeter, it's going to be 6. If I go add up this perimeter, it's also going to be equal to 6. All right. If I go add up this perimeter, it's going to be equal to 8. And if I add up this perimeter, it's going to be equal to 8. All right. And if I go add these values together, I'm going to get 16 plus 12, which is equal to 28. And somehow I've made a mistake. Let me read the question again. So a square is actually a rectangle, Rayon. Somehow I've made a mistake because the ratio should be 1 to 2, and I can't see how I've stuffed it up. Did they say cut into? No, they didn't say cut into equal rectangles. Oh, Andres. What a chop. Sorry. Okay, I added up the area of the original triangle incorrectly. Thanks, Andres. All right. So 3 plus 4 plus 3 plus 4 is equal to 14. The smaller area is 14. The bigger area is 28. And so that ratio is 1 to 2. All right. Thanks, Andres. Thanks for saving that. Yeah. So however you do it, Sky, you are going to get that. You are going to get it. Okay. Now, alternatively, all right, if you didn't go and add, if you didn't go assign random values, you could have done this algebraically. You could have also just done it semi by inspection, all right? And this is the idea, right? So let me just remove all of this, right? So is everybody with me that if I'm looking at the lengths, I would have 2 of the red lines, okay? If I'm looking at the smaller rectangles, all right, there, if I add those 2 together, then I've got 1 red line. There, I've got 1 red line. For the top triangle, for the top rectangles, I've got another red line. And for the bottom rectangles, I've got another red line. Okay, so in my mind, for the big rectangle, I had the top and the bottom were 2 red lines. For the smaller rectangle, I had 4 red lines, and it was twice as big. Similarly, if I did the breadths, I would get exactly the same thing. And so because I'm double counting the middle lines, the perimeter is always going to be twice as big. It doesn't matter how you set this up. Okay, cool. All right, so Issa, 100%. If you did it algebraically and you went like this, so Issa did it algebraically and he went and said, this is, let me do this, A, B, C, D, all right? Then the total perimeter is going to be A plus B times 2 plus C plus D times 2, which is just going to be 2A plus 2B plus 2C plus 2D. Okay. If I look at the smaller rectangles now, this is also going to be C, that's going to be A, this is going to be D, and this is going to be A. For this rectangle here, I'm going to get 2A plus 2C. For this rectangle, I'm going to get 2A plus 2D. All right. For the red rectangle, all right, I'm going to get 2B plus 2C. And for this rectangle, I'm going to get 2b plus 2d. And if I simplify this, I'm going to get 4d. I'm going to get 4a. I'm going to get 4c. And I'm going to get 4b. And so this area is going to be 4a plus 4b plus 4c plus 4d. And does everybody see that is twice as big as this? Okay, so if you go randomly assign variables, you do it logically or you do it algebraically like Isa did it, all of those are legit answers that are going to get us to the solution. Okay, so good job, guys. Then, nice, Isa. This question is really nice. This question is linked to the question that we did last week. So give this one a go. Cool, Josh. So, Merlin, what you can do is, do you see that if I go and, oh, that was terrible. If I go look at that red triangle, do you see that that is a quarter of the whole rectangle? Okay. So if I were to go draw a rectangle like this, oh, didn't want to form a rectangle, let me try again. If I go draw a rectangle like this, ooh, I don't know why it's not called, okay, anyways, whatever. So if I go cut it like this, all right, do you see that these areas are equal and these areas are equal? And so therefore, if I look at this red triangle, it's a quarter of my, I don't know why mine, yeah, it's a quarter of my whole rectangle. This red triangle at the bottom here is also a quarter. Right. And this yellow, oh, sorry. And this yellow triangle is a half. So maybe that will help. Okay. Not sure if Josh and Isa are right, so just, yeah, keep going. All right, do we need another hint? Okay. So, firstly, Petrus, were you happy that my red triangle is a quarter, my other red triangle is a quarter, and my yellow triangle is a half? Okay, cool. Now, if I look at this one, isn't that a quarter of a quarter? I mean, a quarter of a quarter. Cool. So if I've got a quarter of a quarter, we can go from there. Okay, so let's maybe start in the bottom here. All of these triangles, let me do not the yellow. Yellow is hard to see. Let me do pink. All right. All of these triangles have got the same base and have got the same perpendicular height. And so all of those pink triangles have got the same area. Okay, so let me start this question. All right, so there's multiple different ways to do it. I'll keep moving this, so let me grab this and move it back. All right, so like we discussed, if I take my rectangle and I split it like I have here, is everybody with me that all four of these are congruent triangles, and thus the area of all four triangles are equal? Tepi, are you asking a question? No. Okay, cool. All right. All four of those triangles are congruent triangles, so that all of them are equal to a quarter. But Tepi, I'm just muting you again. All right. So if both of these are equal to a quarter, that means that this area is equal to a half. Okay, cool. So then, so this red triangle at the bottom there is equal to a quarter of the whole triangle. All right. But I know that if I just look at this bottom section, all four of those pink triangles have got the same base and the same height, and thus they've got the same area. And so if I work out just this first pink one, is everybody with me that this first pink one is a quarter of, which is multiplication, of a quarter? This guy is also a quarter of a quarter. All right. And I'm adding all of them. This guy and this guy are also a quarter of a quarter and a quarter of a quarter. Now, all of these are going to be equal to 1/16. And if I add them together, I'm going to get that this is 4/16, which is equal to a quarter. All right, cool. So I know definitely that these four pink triangles together are equal to a quarter of the whole triangle. Okay. Cool. Everybody with me? All right. Then I'm going to look at the yellow triangle now. And does everybody see that both of those are equal to a third? All right. And so is everybody with me that if I look at the yellow triangles, I've got a third of a half plus a third of a half, because again, this whole area is equal to a half, and I've split this into three equal triangles with the same base and the same height. all right? And so a third of a half is a sixth plus a sixth, which is equal to 2/6, which is equal to a third. And so all I need to do is add a quarter and a third. And I'm going to get to your question now, Tsepi. If I do that, I'm going to get, I need to get the same denominators. I'm going to multiply by 4 and 3 at the bottom. And I'm going to get 3/12 plus 4/12, which is equal to 7/12. And that there is my answer. Okay. Tsepi, question. Tsepi, you raised your hand. Is that a question? Your mic is on. Okay. Tsepi, are you asking a question? No? Okay, I'm just going to lower your hand and I'm going to mute you. Okay. All right. So again, you can look at the fraction of each one of these guys, and then you can add up all the fractions separately. That's how I did it. Alternatively, what you can do is you can go and assign, oh, sorry, I meant to do this. Okay, so that was quite challenging, all right? Alternatively, what you can say is the whole area is equal to 48. Okay. So Romeo, yeah, so cool. So I'm giving it a random area of 48. Okay, just because 48's got lots of factors. Cool. All right. Now, if the whole area is 48, Haley, are you with me that this yellow piece here is equal to 48 divided by 4, which has an area of 12. Cool. So this whole section at the top has got, let me do it in this. This whole triangle has got an area of 12. All right. And are you with me that, again, what did we decide? We decided that all four of these triangles have got the same area. Okay. And thus I'm just going to divide this by 4 and I'm going to get 3. And so this has got an area of 3 and this has got an area of 3. Similarly, at the bottom, this has got an area of 3. This has got an area of 3. Then what I'm going to do is I'm going to take the whole area and I'm going to divide it by 2, which is equal to 24, because I know that this whole section there is half of the triangle. Okay. And so I'm then going to go 24. This is a third and this is a third. So I'm just going to 24 divided by 3. And so this is 8. This is 8. I can add them all together and I'm going to get 6 times 2 is 12. 12 plus 16 is 28 over 48. I can simplify that and get to 12. All right. Alternatively, I think this is what Josh did, is he went and assigned random values to these guys. And he said, this is 2, this is 2, this is 2, this is 2. All right. This is 12. And so this is going to be 4. This is going to be 4. This is going to be 4. If he does that, he can work out the area of the whole rectangle, and then he can work out the area of this guy, because if the whole length is 12, then I can go work out that that is a half times 2 times 6, half base times height. This is a half times 2 times 6, half base times height. This is a base of 4 and a height of 8, and I can work out this area, this area, this area, this area, this area, and this area. And so that's probably potentially the quickest way to do it, the way that Josh did it. Again, I think it's important to know how to do it algebraically, because going forward, sometimes we're not going to be able to do it by ourselves. Okay, so Josh, is that how you did it? Oh, you did it with variables. Oh, okay, cool. Okay, so you also did it algebraically, except you did it with variables. Isa, how did you do it? Same as Josh? Same as I did it initially? Okay, cool. All right, so let's look at this question. I particularly like this question. This question has got a little bit of a trick that comes up all the time. We can discuss it when we get there, but give it a bash. Same as Josh. Okay, cool, Isa. All right. So, draw an equilateral triangle, draw a regular hexagon, and see what comes out. Okay, getting answers of 2 to 3. Not sure if that's right. Again, give it a bash. Not sure, Tsepi. Okay. I'm getting multiple answers that are 2 to 3. Okay. I don't know if that's right, but this is the trick that I kind of know. I don't know if you guys did it differently, but yeah, and my hexagon is not amazing, but if I draw lines like this might not work amazingly because my hexagon is not that great. All right, is everybody with me that this is a revolution, and so all of the angles must add up to 360, but the way that I've drawn it, does everybody see that all of those triangles must be equal, right? So I know that this must be equal to this, 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 must be equal to this. And so all of those triangles are congruent triangles. And so what I'm thinking is that if I divide 360 by 6, I'm going to get 60, 60, 60, 60, 60, and 60. All right. If I go further, does everybody see that this is an isosceles triangle And so these two angles are 180 minus 60 divided by 2. And what does that give me? 60, 60, 60, 60. You get the idea that all of these triangles are equilateral triangles. So I can always split. A hexagon into 6 equilateral triangles. Okay, all right. And let's give, yeah, okay. Is everybody happy with that? Okay. So let's give these triangles sides. And so I know that the perimeter of this guy is equal to 6x. Okay, and all of these triangles are x by x. Okay, if the perimeter of the hexagon is equal to 6x, the perimeter of the equilateral triangle must be equal to 6x, and so this must be 2x, 2x, and 2x. Okay, now another trick that you need to know is that an equilateral triangle, and again, this is maybe not going to look so hot because my initial drawing wasn't so great, but if I go and do that, all right, this is 60, this is 60, and this is 60. If I go split it in half, all right, that makes this an isosceles triangle, and this is also going to be 60 and 60, and so all of these, in all of the triangles on the inside, are also equilateral triangles. All right, and so if the whole length is 2x, then this is x, 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 and this is x. All right, does everybody see that here I've got 4 triangles that are equilateral triangles with side length x. Here I've got 6 equilateral triangles with side length x. All right, and so if I've got 4 of the same to 6 of the same, the ratio is going to be 4 to 6, which is 2 to 3. Okay, so no, for our calculators allowed for the Maths Olympiad? No. Okay, all right. Did everybody do it like I did it, or did you guys do it differently? Okay. Same? Differently, Isa? That's fine. You assigned random values. Joshua, that's also fine. Oh, wow, Josh, hectic. All right. Are you happy that... Josh, that's insane. All right. That's very impressive. All right. But are you happy that my way is good? And this is so crucial, is a hexagon can be split into 6 equilateral triangles, and an equilateral triangle can be split into 4 equal equilateral triangles. This is absolutely crucial. You have to know this going forward. This kind of concept comes up all the time. Okay, let's do this one. I'm just going to go fill up my coffee cup again. I'm going to come back. I'm a little bit of a caffeine addict. Yeah. That's what I did, Issa, is 4 triangles, 2 6 triangles, 4 to 6, which is 2 to 3. Yeah. Oh, yeah, without all the X's. Yeah, fine. But without the X's, you wouldn't necessarily know, Pooja, that you wouldn't know necessarily that the equilateral triangles are the same. All right. So somehow you need to show that the equilaterals are the same. Whether you go and use X's or whether you assign random values, you have to show that they are the same. Okay. So multiple different ways that you can do this. I could think of 3 ways to do this. I'm just going to do for myself the easiest way. Okay. Cool. So is everybody with me that I'm going to go make... Seppi, are you asking a question?
No.
Okay, cool. Let me just mute you then. Okay, cool. All right. So what I'm going to do, and there's, again, like I said, there's multiple different ways, probably all ways to do questions. But what I'm going to do is I'm going to go and make a construction there. So I'm going to complete... Actually, let me not do that dotted. I'm going to go complete this. That was incorrect. I'm just going to go complete this rectangle. All right. And I've drawn it badly, but there it is. Okay. So move this a little bit. Okay, it looks a little bit better, but yeah. Okay, you get the idea. Okay, Afif, are you asking a question? No. Okay. Cool. So is everybody happy that what I can do is I can work out the whole area of the whole rectangle, which is going to be A plus B times B. Sorry, that's a B. So the length is A plus B, the breadth is B, and so the area of the whole rectangle is going to be AB plus B squared. Done. All right. And now what I'm going to do is I'm going to subtract the yellow area. I'm going to subtract the pink area, and I'm going to... Oh, why is it not working? I'm going to subtract the blue area, and that's going to give me the shaded area. Okay, everybody happy? All right, makes sense. I'm going to go the whole rectangle minus yellow, minus pink, minus blue, and that's going to give me the area of the shaded region. Now, let me just fill in. This is A, all right? Now, does everybody see that if this is B, all right, I've gone and completed the triangle, and so this whole area, that whole breadth is B, and so this small little one is B minus A, okay? And so I can just go say that the yellow area is going to be, let me move this all to the side a little bit and just create some more space for myself. I haven't left much space for myself. All right, so let me do that. Let me do this, and let me do that. So the yellow area is just going to be minus a half times B minus A times A plus B. Okay, half base times height. Then the pink area is just going to be a half B squared, and the blue area is just going to be a half A squared. Okay, Petrus, questions? What do you mean question mark? Where you not happy? Yellow. All right. Are you happy that this is a right angle triangle? The base is b minus a, and the height is a plus b, and I'm just going a half times base times height is the yellow area. Does that make sense, Petrus? Okay, cool. All right. And then for the pink area, I've got a half b times b, and for the blue area, I've got a half a times a. And this is just something that I need to now simplify out. Sorry. I don't know why this is. Actually, what I'm going to go do is for this, I'm just, instead of doing a plus b, I'm going to do b plus a. So I'm going to get ab plus b squared minus, and then is everybody with me that this is a difference of two squares? And so when I multiply it out, I'm going to get b squared minus a squared. So I'm going to get a half b squared minus a half a squared. All right. And then I'm going to get minus a half b squared minus a half a squared. All right. And when I multiply this out, I'm going to get a b squared minus a half b squared plus a half a squared minus a half b squared minus a half a squared. The half a squareds are going to cancel out. All right. If I go 1b squared minus a half b squared minus a half b squared, 1 minus a half and a half, those cancel out, and all I'm left with is a b. Okay. So my answer is just a b. That is the area of the shaded region. Okay. Alternatively, I could have done a different construction. All right. And I could have made a construction there. And then I can work out the green triangle, because I know what the base is, and I know what the perpendicular height is. The perpendicular height is b minus a. Let me put that height outside. There, that's the height of this triangle, b minus a. For the yellow let me do that in a different color. For the yellow triangle, half a squared, easy. And for the orange triangle, the base is a, the height there, the perpendicular height outside of the triangle is b, and so I can work out the areas of green, yellow, and orange and add them up, or I can work out the area of the whole triangle and then subtract everything. Okay. Oh, so in this case, Pooja, I am adding triangles. I'm not subtracting them. All right, so I don't care about the little triangle at the top there. I'm adding the whole green triangle, the yellow triangle, and the orange triangle. Initially, I did the whole rectangle minus the white triangle, the white triangle, the white triangle. Now I'm just working out the area of the shaded triangle. Okay, cool. There are other ways to do it. In my mind, those were the easiest ways. Okay. I mean, in the yellow, pink, and in that case, that triangle was included. It was all the orange triangle, and that orange triangle has got a base of b minus a and a height of a plus b. Okay, so I did add that in. Unfortunately, there it is. There's my first answer. Okay, so Tatenda, this will be on the what's it called? on the recording. So if you miss anything, you're welcome to go look at it again. Yeah. Okay, cool. Let's do the next question. Okay. So this is definitely the hardest question today. I'm only going to give you like 2 or 3 minutes to look at it, and then I'll do it because, yeah. Josh, did you do this beforehand? Or you do it now? Oh, cool. Very good. Okay, so somehow, again, what I'm going to have to do is I'm going to have to set up an equation. Okay. Now, I don't know quite how that's going to work, so I'm just going to start. Okay. Again, multiple different ways to do this, but yeah, I'm just going to give it a bash and see what happens. Okay. So again, this is the hardest question. I don't want to spend too much time on this, but I do want you to kind of start thinking in this particular way, and so I'm going to jump straight into it. Okay, cool. So it says that these are quarter circles. Cool. And it also says that the side length of this whole thing is 2. All right, and so I don't know what this area is at the top here, so I'm going to call it Z, and the bottom I'm also going to call Z. Okay, now is everybody with me that I can automatically now start and I can say x plus z plus y is equal to 4. The area of x, the area of y, the area of z, and the area of z all together add up to the area of the whole square, which is equal to 4. Obviously, I can simplify that to 2z, and there I have an equation. Okay, now I'm not quite sure how that helps me because I want to be able to figure out, I want to know what x is, and I want to know what, I want to relate x and y, and the problem is now I've got z's. Oh, sorry, wrong color. Now I've got z's, and the z's are stuffing me up. All right, so somehow I want to get z in terms of something else so that I can replace it and only have an equation of x's and y's, and then I'm going to manipulate that equation and somehow get y minus x. So that's where I'm going, is I've got an equation with x's and y's, but also with z's. I only want an equation with x's and y's, and so I want to get rid of z, and so I need to figure out what z is. Okay, cool. So is everybody with me that if this is a quarter circle and that circle has got a radius of 2, all right, then I can say y plus z is equal to a quarter of the whole circle. The whole circle is going to be pi times r squared, and the radius of the circle is 2. And so I'm going to get y plus z is equal to a quarter times pi times 4. Okay, so if I rearrange this, All right. Is everybody with me that I now have a quarter times 4 times pi? The 4's will cancel out, and all I'm going to get is that y plus z is equal to, oh, not 4, is equal to pi. All right, let me move all of this there. All right. Now, why this is helpful? Again, this was my original equation, and I didn't like it because I wanted x's and y's, but now I've also got z's, and the z's are just an issue form. All right. But is everybody happy that I can go and say z is equal to pi minus y? Okay. And so what was the issue? Z. What do I have here? Z. And so what I'm going to do is I'm going to take this and put it in the place of z. And I'm going to get x plus 2 times, what was it? Pi minus y. Pi minus y plus y is equal to 4. Okay. And if I do this, I'm going to get x plus 2 pi minus 2y plus y is equal to 4. All right. And I'm going to get x plus 2 pi minus y is equal to 4. All right. What do I want? I want a plus y and I want a minus x. Currently, I have a minus y and a plus x. I want it the other way around. And so I'm going to take the y and the x to the other side. I'm going to leave the 2 pi on this side. I'm going to subtract the 4 on both sides. And now I have solved what y minus x is. It's 2 pi minus 4. Okay. So again, start by somehow setting up an equation. Then be like, what in this equation do I not want? Well, it's the z's. So go find another representation of z in terms of either x and y, and then go remove it, and you'll be able to then isolate y minus x. Okay, so like I said, that question is fairly challenging, but I just wanted to do it because it's important to start thinking in this manner. Okay, nice and easy question to start with for this counting section. Kiara, you've got a question.
Yes, sir. I'm saying that Olympiad, those type of questions be there, sir? Like those type of hard questions?
Potentially, but that'll be a second. Well, it'll either be like the 20th question in round 1, or it will be a round 2 question. So, I mean, round 1 is going to be more of the easy questions, and so that will only appear like right at the end of paper 1, but even that potentially is too hard for paper 1 and will be in paper 2. But yeah, so there's definitely going to be lots of doable questions. Okay, cool. So Petrus, be careful. Guys, these questions are easy, but you have to make sure that you get these questions right. Again, just because you have got an answer and that answer is one of the options doesn't mean you are correct. Okay? And so it's very important that you that you get these questions right. Again, if you get an answer and that answer is on the list, it doesn't make you correct. Now, if there's this queue, all right, Jess is here somewhere. If she's 18th from the front, that means there's 17 people in front of her. If she's 35th from the back, that means there's 34 people behind her. And so I'm just going to go 17 plus Jess plus 34. And this is equal to 52. All right. Alternatively, you could have said this is 18 and this is 35. But what have I done? I've double counted Jess. And so I need to subtract one. And yeah, so if you go left and right and add Jess, or you do everything and subtract Jess because you've double counted Jess, either one of those is cool. But again, you have to be very careful with these questions. This is also a nice, easy question. Okay. Okay. So they say if all the square roots of all the numbers from 1 to 105 are written down, how many of them are whole numbers? So is everybody with me that 1 works, right? And 4 is going to give me 2. And 9 is going to give me 3. And 16 is going to give me 4. So I definitely know that 1, 2, 3, and 4 are in. I know that 5 times, so 25 will give me 5, that's in. I know that 36 will give me 6, that's in. I just need to know at what point does it end? At what point can I not include it anymore? All right. And so very simply, I know that 30 times 30 is equal to 900. So 900 is in because it will give me a square root of 30. All right. So I definitely have 30. All right. The question is, what is 31 times 31? Well, in my mind, this has to be bigger than 905. I mean, between 3 squared and 4 squared, I went up by 7, right? Between 4 and 5, I went up by 9. Here I'm going up by 5 for bigger numbers. Surely that's going to be over 905. And so I can definitely just say 30 numbers are going to be square numbers. Okay, cool. This question? All right. So again, this question is not hard, but you have to get it right. Because again, 49 will be there. 51 will be there. So whatever you get, whatever answer you get, if you've made a careless mistake, that answer will be in the list and you might be like, cool, I've got it. No, you haven't. Be careful. Make sure you get this question right. So strictly between, so that I'm not including that. So I'm starting there and I'm ending there. All right. So is everybody with me that actually I'm just talking about 1 to 99? I mean, the other numbers, Joshua, what are you talking about? Oh, yeah. Yeah. I mean, the fact that it's 99,900 is, yeah, 100%. They're just making it challenging. But is everybody with me that at the end of the day, we actually only looking between 1 and 99? Cool. All right. So is everybody with me between 1 and 99, there are 99 numbers. Okay. If it was 1 to 100, is everybody with me? There would be 100 numbers, 50 would be odd, and 50 would be even. All right. But if I take away 100 and I only go to 99, I'd still have my 50 odd numbers and I would have 49 even numbers. And so my answer is 50. I like this way of doing it. They might have asked for even numbers, and that's, again, you just need to think, you just need to make sure that you're processing this nicely. If I can break it down just to 1 to 99 instead of 99,000, it's much easier. It's much easier to conceptualize. So if you can make it smaller for yourself, make it smaller for yourself. Okay, cool. Yeah, do this question. This question is quite nice. I like it. Again, this is going to be right towards the end of your question paper in round 1, if it even appears in round 1, as this is a very challenging question. Joshua, that is not right. Okay, maybe Issa, maybe Josh. Let's keep on going. So in questions like this, don't just look at the question. To be honest, when I read this question, I was like, what are they even asking? And so what I did is I just started and I was like, cool, what about this option? And then once I had done one option, then everything came alive. All right, so don't look at the question, just start the question, start putting in options, and then try to see if you can recognize a pattern. Okay, so in my mind, these questions are always, even the next question, or no, this question, like they're hard to kind of just understand. All right, so just start. I don't think that's right, Kellen. Okay, cool. So this question is also quite challenging, so let me give it a bash, and then we can move on to the next question. It says, a tick and a cross are to be placed in the grid of 16 blocks alongside, no more than one in a block, and once I've chosen, no row or column of 4 blocks may contain both symbols. So if I start and I put the tick there, I'm only placing one tick and one cross, right? So if I put the tick there, that's not going to work because now they're in the same row, right? That's not going to work. So all of those are out. I'm not allowed to use those, and I've got 9 options. Is everybody with me? So if I place the tick top left, I've got 9 options. Okay. Now let me place the tick again. Let me place it there. Where's the tick not allowed to be? The cross. It's not allowed to be there, and it's not allowed to be there. So how many options are left? Oh, it seems like again, there's 9 options. Is everybody with me? All right. And if I place the tick here, All right, I'm not allowed to put it there, and I'm not allowed to put it there. Is everybody with me? How many options are left? There's 9 options left. All right, so every place that I put a tick, all right, I've got 9 options left. All right, and so how many places can I put the tick? Well, there's 16 total blocks where I can. Is that a question?
Yes, sir.
Haley? Yeah. Okay, cool. So there's 16 total places where I can put a tick. I can put a tick in each one of these blocks, right? And wherever I place the tick, I'm going to have 16 options to place a cross. And so it's just going to be 16 options. And for every one of those 16 options, there's going to be 9 options. And 16 times 9 is indeed 144. Okay, cool. You added them. Okay, cool. All right, cool. So this question is excellent. So I really like this question. We're not going to have time to do, there's 3 questions left. So yeah, I really like this question. These game questions do come up every now and then.
Sorry, sir.
Yeah, Haley.
There's been a connection problem. I couldn't hear the last question.
Okay, not a problem, Haley. Is the recording will be of this will be posted on the Google Classroom. So if you miss anything, you can just go rewatch it there. Okay? Thanks, Haley.
Thank you.
All right. To this question, this is the last question that I think we're going to be able to get through. Maybe we'll get through another one. Yeah, we'll see how long this question takes, Andres. Maybe we'll get through another one. All right. Okay, that's excellent. All right. So I didn't expect you guys to get this so quickly. You guys are too clever. All right, so let me actually draw a square. Okay. Let me draw a square in here. This is not amazing, but we're going to work with it. All right, cool. So let me just copy this, copy, and then let me make it a little bit smaller actually. All right, cool. And just copy it. And again, my thing is sometimes cool. You're not going to see it immediately, so just start. Keep on doing this and see somehow if there's a pattern, right? And so let's just continue with what they had. So they had 1, 1, 1, 1, all right? When they looked at that one. Then they went and looked at this yellow one, all right? And they got 1, 1, 2, 2, 1, 1. Cool. Now, let me go choose another square. Let me choose the square at the bottom, all right? And so I'm going to add 1 to this one and to this one. So I've got 1, 2, 1, 1. And then I'm going to get 2, 3, 1, 1. All right. Then what I'm going to do is I'm going to look at the other square. I'm just looking at all of them. Let's see what happens. And so this is going to stay... These are going to stay the same, all right? And what's going to happen is I'm going to add 1 to all of these guys. I'm going to get 4, 2, 2, 1. All right. And then let's just pick another random, this one more. All right. And then what I'm going to get is I'm going to leave the outside. So I'm going to get 1, 2, 1, 2, 1. And then what am I going to add 1, 2, these guys. And so it's going to be 3, 5, 2, 3. Now, I think the big takeout in all of these is, does everybody see, and I'll do this in a little bit darker. Let me do it in that color. This block is added to when I look at the top left square. This block is added to when I do the yellow square. This block is added to when I look at the bottom left square. This block is added to when I look at the bottom right square. This block is added to when I look at the bottom left square. So does everybody see? The other ones aren't going to be added necessarily, but every time I look at one specific square, the middle block will always go up 1, right? So that's my first takeout. So if I look at this question, if that were right, I've added to it 18 times. Here I've gone once. Oh, let me do that in a different color. I've gone and used, I've added once, twice, 3, 4, 5 times. And does everybody see what's my answer? 5 times. Because every time that I add a square, I add 1 to the middle. Okay? But when do I add something to this guy? Only when I do top left. When do I add something to this guy? Only when I do top right. When do I add something to the bottom left? Only when I do bottom left. And when do I add something to this guy? Only when I do bottom right. And again, there it goes to 2. Why? Because now I've done the bottom left-hand triangle twice. And so what do we see? That means I've done 1 top left triangle, 1 top right triangle, 2 bottom left triangles, and 1 bottom right triangle. And so what do we see? And this is the big takeout, is that all of the corners added together must be equal to the middle number. All right? Because the middle number will get added to every time I do a square, and the corner squares are only going to be added to when I do the square in that section. And so I can go 4 plus 5 plus 6 plus 7. I can go, that means I've done 4 top lefts, 5 top rights, 7 bottom rights, 6 bottom lefts. And what does this equal to? It equals to 22. But this is 18. So that doesn't work out. This says I've done it 18 times. This says I've done it 22 times. This, unfortunately, is not true. Okay. So if you describe it like I did, guys, I know you guys don't need to tell me about the time. I am watching the time. That's why I said there was only one question left. All right. So here you can, so I would just explain it like I did. So I would write out and I would say the middle square is, I add 1 to the middle square every time I do it. I add 1 to the corners only when I do the corners, and then you can explain it like that. That would be a third round question. Duncan, question. This is going to be the last question, and then we'll end it there. Was that a question, Duncan?
Yes. I worked it out differently.
Yeah.
I took 4 and 6, and that added up to 10. So, and 5 and 7 equal 12, and I knew that 10 and 12 should equal 22.
Yeah, 100%. So you did exactly the same thing as I did, except you just added them in 2 goes. Yeah. But yeah, that's perfect. Good stuff, Duncan. All right, cool. All right, excellent, guys. That was our last lesson. I really enjoyed doing this for you guys. And yeah, really, I hope you guys do well next week, Thursday. I really want you guys to, if you haven't, sign up on the SAMF website and go do past papers. The only way that you can get good at this is by practicing and by seeing a lot of these questions over and over and over again, because a lot of the questions are repetitive questions just within a different concept. Okay, so do 5 or 6 past papers and you'll absolutely smash Thursday's Maths Olympiad. Thanks so much, guys.
Thank you for the lesson, sir.